So in the last class, like in the demo session, we have got an overview of what is DevOps, why DevOps, like why were we implementing the benefits of DevOps. We have got an overview, right? We discussed the big picture of DevOps. Today, let us proceed into the first tool in our course, which is a version control system, right? Like we discussed, we'll be talking from the basics to the advanced concept. So first, let's begin with what is a version control system, why we need it as a DevOps person, and what are the different aspects of it. So let's get started. So here, anyone who are using any version control system, who knows a version control system? Anyone here?
Yeah, so version control system for GitHub or cloud.
Okay. So let's talk about what a version control system is. To understand this, let's take a simple scenario. Like let's suppose, let's say there is a team of people, okay, and there were some bunch of files they're working on. Let's say file 1, file 2, right? They were making some changes and they were like using these files from a shared location. Okay, they have their files kept on a shared location. Let's suppose there is a person or a developer D1 who downloaded this file 1 to his computer. At the same time, another developer D2 also downloaded this file, the same file, file 1. Okay, so both of them made the changes to this file locally, and then D1, like a developer 1, kept this file back first on day 1. Okay, let's say on Monday he kept this file, right? And then developer 2 placed his file back on Tuesday. So if that is the case, the file 1 on this remote location will have which person changes? At the end, like on the third day, which this file will have which person changes? File 1 will
Developer,
have, yeah,
developer two. Developer two changes.
developer 2 changes. Means what is happening here? Developer 2 changes are overwriting the changes of developer 1, right? Developer 2 doesn't know this, like he's not doing this consciously. He doesn't know this is happening. Even developer 1 doesn't know this. So if this keep on continuing, right? If one person changes, keep on overriding others, the project gets messed up or corrupted in no time, isn't it? And also here, I'm talking about a scenario where they were not using any version control system. So if no version control systems are used, right, the changes would be overwritten or else changes might be lost, correct? So how to handle this scenario? How can we see that the changes are not overwritten? How the project can be maintained safely, securely? Because see, people will be concentrating on developing their logic or else making changes. They can't just sit and see whether their file is being secured or anyone else changes are being messing up his changes. If this kind of monitoring they can't do, right? So that's where comes version control systems into picture. Version control system is something which can help you, right, with this a kind of securing the files. Means version control system is something which will not allow people overwriting changes of others, right? This will not happen if you use version control system. Means it allows people to work on the same file at the same time, like simultaneously people can work on the same file. Version control system allows us that. Not only that, let's suppose something went wrong, application crash, we want to fix that very quickly, right? Let's suppose till 7 o'clock application is fine, something went wrong at 7:30. Means you want to see what happened in between. Means we need a system which can provide such detailed logging. Like let's suppose at 7:15, person A or else developer D1, whatever it is, like this person made changes to file 1 on line number 7, which led to this changes. So if I have this kind of detailed logging, including the timestamp, right, it's very easy to revert or undo the changes, right? Means it helps in a great logging, right, which is not possible if you do manually, right? That's another advantage. Also, many other advantages, like let's suppose you are working on file 1, this is a version 1. Client want to make some modifications and you made the like you edited the same file and made a new version. Means you have deleted or overwritten this version 1, right? let's say if client want the same old version after 6 months, it will be a lot of rework, isn't it? It's no more you have to again do this rework again, develop this file one, version one, right? So don't ever delete the versions, right? This version control system will help you maintain backups, maintain versions. All of that will be taken care by a version control system, right? So that is what is a version control system. This is being used. Version control system can be used to manage any static files, any files. Your files might be written by developers. They might be Java program files, PHP, C Sharp, whatever, Python or else shell script, your Terraform config files, your Kubernetes manifest files, all of them can be version control. Even you can use it for your personal purpose. Let's suppose you have some files to manage, some documentation, you have your property documents or whatever, even those can be version control. Means any static documents can be version control. And it is mandatory for developers. They were using it mandatorily because they have a lot of files. But like days were changed. Now even DevOps person, ops teams will have their config files and scripts, everything. Even everything should be version controlled, right? So not only developers, everyone, whoever want to enter into IT should learn this. Am I clear why we are learning it? It's not, you are not managing your code, okay, not the program files. It might be your configuration files. Okay, so everyone should know how to use version control system. That's the first thing, right? To manage your files. Second thing, okay, developer wrote the code, they place the code. You need to pull the code and implement the CI/CD pipeline, right? Means Git should be integrated in the CI/CD. So from that perspective of CI/CD, you should learn Git, right? So we will be learning it from all the perspectives. First, we'll be learning it how to manage the code base. Then means how to manage your files with Git. Also, we will learn how to integrate it in the CI/CD pipeline. First, we will learn from the perspective of managing your project files, your configuration files. Am I clear why DevOps person needs version control system? Because there were so many questions related to this part in the previous demo. So are we clear now? Whoever having such question. So everyone should know version control system. So as a DevOps person also, we are learning it. First, we will learn it from the perspective of managing your files. Then we will learn it from the perspective of integrating it in the CI/CD pipeline. Am I clear with this?
Yes, please.
Yes.
Right?
Preeti, I
So
have a doubt here.
tell me.
Like, yeah, as you told, like if a developer wants a file which he has made changes like 6 months back, and we can get the details after 6 months as well. Like, don't you think this has a disadvantage? Like, it will create multiple copies of that file. So within this 6 months of time,
It will not be
we
maintaining multiple copies. Okay, it will maintain the versions. How it is, it will be clear when we do the hands-on. Okay, whatever we are discussing, we were going to do hands-on practically. Okay, in some time today we'll start the hands-on. Maybe this scenario might be coming up in the next sessions, so that you will get a clarity. It will not maintain the copies, it will maintain the versions. How Git maintains it is a differently it does. Any more questions? Okay, so we understood what is a version control system, correct? Now that we understood what a version control system is, let's talk about the types of version control systems. Means based on their architecture, they were categorized. Okay, they were categorized into different ways, like centralized version control systems and distributed version control systems. So let's talk about centralized version control system. Centralized version control system is, you can see this diagram where you have a central server or a remote server or a remote repository, whatever you call it. Okay. And you will get the, these are the workstations of individual developers or DevOps person, whatever you call it. Okay. These are the individual workstations. They will connect to this remote repository, get the code, make the changes and put it back. Okay. That's how they work. That's how central version control system works. They were connecting to the remote repository or central server, whatever you call it, get the changes, make the changes in their local and put it back. This is how it works. But this, if you see this always needs network connection, right? If for some reasons networks are disconnected, entire work is altered, correct? That's one of the drawbacks with this kind of architecture. Second thing is, let's suppose the central server crashed for some reasons, or central server is gone or lost, right? Chances of recovery are very less. Like, because changes gone are gone forever. It works like a single source of truth here in this case. And if changes are gone, they are gone forever. You can't revert or you can't retrieve the changes, right? Correct? Those are the drawbacks of the centralized version control system. To overcome these drawbacks, there came distributed version control systems. Let me show you that. So if you see this distributed architecture, you can see here, this is called the central server or remote repository. Here is all the code base. And these are the workstations of individual collaborators or a DevOps person, right? This is the workstation. And if you again closely see here, there is one more repository here, which is called local repository. Means everyone will have their own local repository. This is the central repository or the remote repository. Everyone will have local repository in their system, which is a copy of this remote. And again, if you notice, they will not work directly on this local, rather they will work on another directory called working copy. They will make changes here and push the changes to local repository. From local repository, they'll push the changes to remote, right? So that is how it works. Changes are happening in the working directory. From there, they are pushing to local. From local to remote. Just a second. Yeah. So this is how it's like 3 steps before the changes goes to remote. And here, if you notice, even though network connections are like disconnected, you don't have network, you still can work on local repository. Of course, when you have to push your changes to remote, then you need network connection. But still, you can continue work on the local, right? So no network connections are required until you pull the changes or push the changes. Pull and push are less frequent. These are less frequent because the only once you've done with the complete coding, you push to remote, right? Or else once you want to get the changes, you will pull them from remote. Those commands are less frequent. Majority of the times you work on this local repository, so you don't need network connections always. Only to push or pull you need, but not always. You can still continue working on it, right? That's how network connectivity, even though it's not there, you can still continue your work. Also, because majority of the times you work on your local computer, this is also faster when you compare with centralized version control system. Also, chances of recovery are more because see, even though the central server is gone, everyone is having their local repository, right? So chances of recovery are more, correct? So that's how this distributed version control system overcomes the challenges of centralized version control system. And remember one more thing, until you push your changes to remote, they are confined only for yourself, right? They are only for yourself. All right. So I'm talking about the architecture, right? I'm just repeating this. This is the distributed architecture, right? In distributed version control systems, you have two repositories like remote repository. This is the remote and this is the local. Means every user will have their own copy of the local repository. This is the workstation of each individual user. Okay, everyone will have a copy of remote repository, which is called local repository. This is called local repository. Okay, everyone is having their copy. And this is the remote repository. So even though network connection is not there, work can be still continued on the local repository. Only once you have the remote, means once you have to push your changes or get the changes from remote, you need the connectivity. So that's how it will overcome the drawback of centralized version control system. Even though you don't have network connectivity, you can still continue working on your local, right? You need network connectivity only to push or pull the changes from remote. That's the first thing. Second thing is, here because majority of the work happens on local repository, it's faster because it's just on your system, right? This is faster. Also, even though a central server or remote repository got crashed, chances of recovery are more because everyone is having a copy of remote repository, correct? So chances of recovery are also more. So these are the things, these are the advantages of a distributed version control system. Particularly in the modern DevOps approach, we were using this distributed version control system, and Git is a distributed version control system. And here, before your changes goes to remote, it's like a 3 steps. From working directory, you make changes and push them to local, from local to remote, right? Only once you push your changes to remote, others can see that. Otherwise, like if changes are in local, they are just confined for you. These are the important things about a distributed version control system. Any questions here? Is this architecture clear?
Yeah, the local repository will have 100% of the remote repository, or will there be any storage limitations?
You can get the 100% like complete local remote repository, or else you can have a certain part, like whichever branches you need also. That is also possible. It need not necessarily be complete copy.
Okay.
Any more questions?
I didn't understand about VCS.
Version control system. VCS is a version control system. Which part you did not understand? What is version control system?
So I joined little bit late. So at the ending, you were sending like it's a uh, version control system. That's all I listened. But
Version control system is
what's the use of that?
that is used to manage your files. Like you may have 100 files in your project. How do you maintain them? How do you backup them? How do you secure them? How do you maintain versions of them? That's what a version control system does. And again, in that version control system, there are different types of architectures like centralized version control system and distributed version control systems. We were talking about different types in those version control systems. Right? Version control system is something which will help you manage your files. Like let's say there is a file, multiple people have to work on it, right? That's what version control system will help you without getting the changes overwritten. Or it is something which will help you so that multiple people can work on it. Also, you can maintain versions of the files, maintain backup of the files, detailed logging. All of these are advantages of version control system. Is the architecture of distributed version control systems clear for everyone? Is this architecture clear?
What you have explained, I'll tell you one, like if my understanding is right or wrong, just let me know. Like you've been telling if some code have been pushed or pulled or something, again there is one will be like version of that code. So it will help for it will be helping for us. So which version it is? Currently might be you're telling about I have like some did a research on Google right now. So whatever like if we are in Visual Studio or some any Eclipse or something, so any developer is pushing in a latest version, might be the code is in older version. So you're talking about and that phase, or I'm
I'm not
confused on that.
talking about in particular. I'm talking about what a version control system is. It will help you maintain the different versions. It's not that you delete the older version and just edit the have a latest version. You can have old version as well as new version. That's what version control system help you with. Also, like backing up your files. Okay, multiple people have to work on the single file. It will allow you without one person overriding the other changes. I'm talking about just the features. I did not talk about any scenario as of now.
Okay, no, I did a research on Google. So if a code is in like in 5 years back code, so this version control will help in that, right? You're
Correct.
saying?
Correct. Correct.
And if the same part have been new code, if a developer have been wrote down, so it will help in that in like current code also.
Correct.
I'm getting my
Correct.
answer is wrong, or my understanding is correct or no?
Correct. Correct.
Okay.
See, I have explained version control system. We just started at 7:35. Okay. I have explained that for 15 to 20 minutes. I would request everyone, whoever missed the initial part, to go through that part where I have explained. Recording will be posted in few minutes. But in short, yes, that's what version control system does. I just don't want to go through all that content now. It would not help the team. So please just watch the recording for that. Any questions, get back. But in short, whoever missed or whoever joined late, yes, version control system is something which will help you maintain the backup of the files, maintain the versions of the files, help you secure the files, help you in logging with which person made what changes to which file at what time. All of this can be done by version control system. For elaborative explanation, please check out the previous part. Now I'm talking about the architecture of version control system, which is a distributed version control system. I have explained centralized and distributed. Any questions from anyone in this part? And here in the centralized version control systems, the examples of the centralized version control systems are SVN, TFS. These are some of the examples of centralized version control systems. And distributed version control systems are Git is a distributed version control system. Git, Mercurial. These are few examples of distributed version control systems. And majority of the modern DevOps projects are using Git. That's the reason we were learning Git here. And we have learned the architecture of distributed version control system in general. Now let's talk about architecture of Git in particular. Before that, here is some graph showing the comparison between other version control systems. If you see that, the blue one is for Git. You can see that's a clearly the winner in this category. Can you see the blue one for Git? That's a winner in this category. Right, means that's a more widely used when compared with any other tools. This is the graph from Google Trends. It's a 2020 graph. You can also check out the latest graph. Now coming to the Git in particular, like we discussed, right, there'll be a local repository and the central repository. See, this is the local repository and this is the remote repository. And again in the local repository, like this is the local computer, let's say. This is the local repository. And we should not make changes anything directly on local. We'll be making changes on working directory, move the changes to staging area, from staging area to local repository. That's how it works. See, from staging area to local. But what is the staging area, right? Staging area is also called as index area. It's just a virtual layer. Okay, why do you need this? It is for like a kind of preview or else pre-check before your changes goes to local, right? Preview or pre-check means, let me give you an example. Imagine working directory is another folder, right? You made some 10 files here, out of which you just need to put only 5 files to local. You will move only those 5 files to staging area. Right, so means it works like a preview or else pre-check before your changes goes to local. From local only it can go to remote. It's not that something like from working directory you can push the changes here or else from working directory you put here. No, it doesn't work. From working directory, changes will go to staging area, from staging area to local, from local to remote. This is called Git tree. This is the hierarchy how your changes moves, right? So you can imagine, consider this working directory like another folder where you make your changes, from where you put to staging and then to local, right? Understood this? And then from there you will push to remote. Here, I would like to talk about 2 scenarios, how your local repository can be created. One of the scenario is, let's suppose you joined a project. Okay, it's an old project, already changes are there on remote. It's some 5-year-old project. So you joined this team today. You may copy from remote and create a local repository, correct? That's one way. Another scenario or another use case is, let's suppose it's a new project. There's nothing on remote. A new team is formed now, a new DevOps team where they have to deploy it on Kubernetes cluster. So here you have to create all those Kubernetes manifest files. So you will create a local repository, an empty local repository manually. Okay, you develop your files, then you push the remote. Those are the two use cases how local repositories can be created. Am I making sense? Please feel free to respond and put your questions to the context. Any questions out of context, definitely I'll take it, but at the end of the topic. Is this much clear for all of you? You can message in the chat window, or else you can also put a thumbs up. But please do respond and let's have an interactive sessions.
So the second point, the empty manual you mentioned, right? So first we'll be creating the repository locally and then we'll push, right?
Correct. First step is we are creating a copy from remote. Okay, you are getting a copy from remote means you will create a local repository which is having everything, which is on remote. Second thing is there's nothing on remote at all. So you will create an empty local repository. Like manually you'll run some command, create an empty local repository, then create your files, and then later on push to remote. Got it?
Yeah, thank you.
So those are the two use cases how you can create a local repo. Just remember these things because these scenarios we are going to execute today. Of course, second one, we'll start with second use case today. First use case maybe tomorrow. But just remember these use cases. Okay, that's about local repository. And I'll tell you another interesting thing, very interesting thing. See, this working directory, local repository. Okay, we were talking about there's a working directory, there's local repository, but they are physically the same. Means same folder. If you are Linux person, same directory or same folder. But then how come you call it a working directory and local repository, isn't it? Logically, they are different. How logically they are different? Let me tell you. See, let's suppose this is a folder. I have created an empty local repository. Now, let's suppose you created a file here. You just created a file means it's set to be in the working directory. Okay. Later on, you added the file. Means then it is set to be in the staging area. Okay. Then you commit the file. Then it's set to be in local repository. But physically, it's in the same folder. Logically, it's different. Is that making sense now? Interesting, isn't it? See, Git is a very interesting tool. Initially, it might be tricky, but if you learn it properly with the proper concepts and with the clarity, you will enjoy working with Git. Understood this concept? See, I'm explaining you theoretically. In few minutes, we are going to see all of this practically. Am I clear with this?
So the staging file and committed file will be two files, right? Or is it a single file?
Same file. I'm talking about same file. Let's say, okay, I'll also name it. Let's say I have created index.html, some HTML file or some simple text file or configuration file. Here, our interest is not the files, how to manage them. Okay, it could be used by developers, testers, ops teams, anyone. So let's take a simple text file. You created the file, you just placed the file in this folder, means we'll say it's in the working directory. If you have run the command and added it to staging area, what commands we will learn them. So if you have added them, it's set to be in staging. If you committed this file, then it is set to be in the working directory. Good.
So this operations will not modify the file. However, it will just change the flag from working directory to staging to local.
Yeah, it's not about the content. I'm not talking about the content. Yes. Clear, everyone? A thumbs up will help me, or else you can unmute and speak up. Is it good? Anwar, is it clear? This architecture. If whoever joined late, please put the things like a introduction on hold and continue from here. Is this clear for all of you?
Yeah, it's clear.
Okay, so This is how you have a local repository like a remote and all. Now that we understood the Git architecture, let's get to the hands-on. Okay, means let's see how the staging area is and how it's working. Let's get into those things. Now that we understood Git, let's install Git. See, Git can be installed on Linux, on Windows, on Mac. You can use Git everywhere. Okay, only the installation step differs. Once you installed it, the commands, the concepts remain same whether you use it on remote or whether you use it on local. Yes, Harish, we'll do manually. We'll have to add and commit manually. Why? I'll tell you. Why you have to do that manually also, I'll tell you. Just give me a minute. Okay, now let us install Git. See, we are using Git first on our Windows. Later on, we'll also see it on Linux. But like I said, concepts, everything are same. So just go to Google and type in install Git. You will see the official documentation. For any tool, always prefer the official documentation. Okay, here it is. If you go here you can see, if you go to downloads, here you will see whether it is Windows or Mac or Linux. Click that. If it is Linux, you click this and follow these steps. I'm doing it on my Windows, so I should go for it. If it is Mac, go click on Mac, run these commands. So it depends on which operating system you are doing. I'm again telling only the installation differs. Commands, concepts remain same whether it is Windows or Mac or Linux. So now I am going to Windows. I will download this Windows installer and I'll go through the steps. What are the steps you need to go through? You can just install it by clicking on next button, which is almost self-explanatory and all of you can do that. But if you need any help anywhere, if you're stuck up, I have already shown you this in the last class, right? You have access to this Google Drive. Here you have Git folder. Here it's a Git installation on Windows. Here you have everything with a screenshot, like what you should do, right? So you click on this Windows, you download that, you run that, you just hit on next and just keep continuing it. That's all you have to do. Git will be installed. Just you have to click on next on that installation wizard. Once it is done, go to the start menu and run Git bash. Because I have already installed it, once it is done, you just start this Git bash. It provides you this bash terminal. Can you see the font? Okay, from where you can run any commands. As Git is installed, I can see the version of it. Yes, that's the version. Right, that's all. Git installation is very simple. Okay, fine, Git is installed. Now, Git is installed on my machine. Okay, how do you tell to version control a particular folder? Means my project files might be in separate folder, right? Correct? Yeah, it might be this folder where I have my project files. So go to that folder and we have to initialize it. Means let's take the second scenario. Sometime back we were talking about the use cases, right? Let's assume it's a new project. Okay, there's nothing on remote. I have to create local repository manually. So I would like to manage a file, a folder called Git demo. Say I'm using mkdir. Mkdir means make directory. It's like a command prompt. You use command prompt in your Windows, right? Same way, this is the CLI way of creating a folder. Or else you can also create this way. Just use the Windows GUI, create the folder. Okay, right click. Okay, create the folder. You know how to create a folder. You can do that. Or else the CLI way, mkdir. We will learn this Linux command separately. Just I'm showing you small things here and there. Now go to this Git demo. CD means change directory. Okay, just a normal folder. I'm inside this folder. PWD means present working directory. I'm inside the folder. Okay, here you can see the one that's created. Where did I create? Okay, in the users I have created. Just a second. cd dot dot, it's like a going back. I just want to go to desktop. It's not available. 1 second. C drive. It was showing it's a C drive. Users and this user. Okay, here we have created the folder Git demo. That's fine. Okay, let's go to this folder. Okay, so now I am in this folder. Now I want to make this folder as a local repository. Let's say, like I said, a scenario, there's nothing on remote. Okay, now I want to make this as a local repository and create the files and then later on push to remote because it's a new product. I'm taking up for the second use case. So how do you start Git init? Go to that folder and run git init command. Means that folder becomes the local repository. An empty local repository. This is what I'm saying, empty local repository. Sometime back, I'm talking about these two scenarios, right? This is the one. Second one I'm talking about, right? It has created local repository and it has also created .git folder. It's a hidden folder. To see the hidden folder, ls-a, or else you can also see here. Do you see at the back end in the GUI? .git. This Git demo folder is having .git means Git demo is nothing but your local repository. It's nothing but your local repository created. Of course, an empty local repository. Clear with till this much, everyone? Understood?
Yep.
Right. So that's an empty local repository. I don't have any files. ls will show the list of the files. Or else you can also check this way. These Linux commands we will learn separately. So just list that. Now let's say I want to create a file. Okay, I may just go here. New file. I just want to create new text file. Okay, let's say it's a file 1. Okay, I have created some file 1. I'll open this. Okay, I'll just put hi and save. So I just created a file. Can you tell me where is this file? Where is this file means related with the architectural diagram. This architectural diagram should be in your mind always. I just created a file. Where is this file now?
Staging area. Working directory.
We just created it means where is it?
Working directory.
Let's suppose I'm completely new. I don't know where it is. Git status. Git status is telling you untracked file. File 1 is untracked means Git knows there is a file, but Git is not tracking it. It is asking, it is giving you a clue Git add. Now can you confirm where is this file? It is asking us to add it. Means it's not yet added. Means where is this file?
Working directory.
I want response from every one of you. Where is this file?
Working directory.
Yeah, it's
Working
local
directory.
Working directory. Now what I'll do? Git add file 1. Now can you tell me where is it?
Staging area.
Exactly. See, the status has changed. Earlier it was showing like untracked, but now it was not showing untracked. It was changing changes to be committed. Means where is this file now?
staging part.
Staging area.
Remember this diagram. Where is it? It is in the staging area. Now you want to move it to the local repository, git commit -m. M flag is mandatory. M means message. Some message so that you can understand what that commit is all about. That is user defined. You can give your own commit message. Now, where is the file now?
It's in local
remote repository.
It is in the local repository.
Local repository.
It is in the low. See, nothing to be committed. Working tree is clean. Means whatever changes you have are there in the local repository. Do you see how status is changing? Yes. And remember, we were still in the local repository. We did not go to remote. We'll go to remote tomorrow because we have so many things to be done on local before we go to remote. But understood how your changes moved this way, like from working directory to staging, from staging to local. Let me repeat this with another file so that things should be clear for all of you. Yes. I'm creating one more file in the same folder. Now tell me, This Git demo is your working directory. The same Git demo is your local repository. Am I correct? Do you agree that now? Physically, it's the same folder. Physically, it's the same. Logically, it's different. That makes sense now, right? That statement is making more sense now, correct? It is the same. Your working directory is Git demo. Your local repository is Git demo. Logically, they're different. Okay, now I'm just creating another file here. New file. File 2. Okay. If you want, you can put some content. That's fine. Now I'm going to git bash. If you do ls, yes, you can. Now, can you tell me where is this file to?
Working
directory.
Working directory. That's all. Every change will go through the same process. It will go from working directory to staging. And what will be the git status message telling us now?
untracked
Untracked.
files.
File to untracked.
Untracked, because it's for the first time, it's a new file, it's untracked. Okay, file 2 is untracked. What you should do for Git to track it?
You need to add.
Add.
We need add.
Git add that.
Add a file to text.
Huh?
Staging.
So now what will status give us?
Add to staging.
This untracked message will be gone.
Changes to be committed means it should be
Yeah.
moved to local repository. Now what you can do? Git commit -m, let's say second file or whatever. Okay. So now, yes, all your changes are in the local repository. Now, if you do git status, yes. Got it, everyone? Yep. I'm just quickly creating one more file. I want answers from all of you. I'm just trying to repeat it, but we'll show you few new commands. Okay, let's say file 3. Where is this file?
Working directory.
Yeah,
Working
working
directory, and ls will show the files in that folder. Okay, there is a command called git ls files. This will show the files in the staging area and local repository. See, file 3 is not there. Do you notice that? Yeah.
Yes.
Now I'll do this file. Sorry. Yeah, file 3. Now it is in the staging area and git ls files can show you that now. Right? That's another new command. So now I can do git commit -m, all the files, whatever, some message. Correct? So how many
Yes.
times did I run this commit message by now?
3.
3 times. All your commit history, you can see through a command called git log. Sometime back in the beginning, I'm talking about this, right? It will provide you detailed logging, including the timestamp, which person made what changes at what time. That's what is this. Every commit will generate a commit ID, alphanumeric hash code. Okay. And then author name, your name and email ID. I did not configure them, so it was not showing. Otherwise, it will show you your name and email ID. See, time, Tuesday, November 7th, 8:21, including the timestamp and the commit message. This is very important in real time. That's how you know which person made changes at what time. Of course, these are all on my local repository. They are confined only for myself. I'll push them to remote and also we'll see that. Right? Log will show you the commit history. Got it?
Yeah, Priti, and one more doubt. So can we add multiple files at a time?
You can, if you want to add multiple files, git add dot. All the files can be added, or else git file1.txt, file2.txt. You can also put the names that way. Right? Please confirm me if your question is answered. Got it?
Yeah.
Okay. So git log will show you the commit history. Okay. And yeah, git status command we have seen. And yeah. And then let's suppose, okay, we made some commits, right? And we were creating new files. Is it always about the new file? It might be modifications to the existing files as well, right?
Yeah.
Let's suppose I want to modify this file 1. Okay, and just adding some dummy lines. Okay, if you want, if you are a developer, you may write your own programs, or else some just text contents will do. Okay, here it could be our Kubernetes files, Terraform files and all. We will be using this Git throughout our course. So first we were learning it so that we are managing our files with this. So until then, we were using some dummy files. Okay, I made a modification. Now can you tell me where is that modification? Where is that change?
It's in working directory.
Exactly. See, Git works with respect to changes. Listen carefully. Git works with respect to the changes. It might be a change, might be creating a file, means change might be creating a new file, change might be deleting a file, change might be modifying a file. It could be anything, but the concept is same. Everything will go to the working directory, staging area, and local repository. And because I made a change now, right, it's in the working directory. If you want, you can see the message. Git status. What will it tell you? What it gives us the message now?
Untracked.
No. Untracked you will get only for the first time. It's not a new file, correct?
Yeah.
It will tell you. Did I save it? 1 second. See, it is not saved. That's why when I do save status, it was showing the same. Let me save it. Yeah, okay, now it is saved. Now you run the status. See, it's not saying untracked, but what it is telling us? Unstaged. Not staged also means what is it? Not staged means you check this diagram. Not staged means where is it? Working directory. But
Working
there is a difference. There is a difference between unstaged changes and untracked changes. This is important from the point of interview as well. If someone want to test you the concepts really, how expertise you have, untracked and unstaged changes. Untracked is for new file, right? This is for not a new file. File is modified. Some changes were there, right? Now what you have to do? It's a modified. Now again you can do git add, git commit. Okay, like earlier. Okay, the same way you will do here also, right? Add and commit. But because it's not a new file, you can also add and commit with a -a minus. In the single command you can do if it is unstaged. But if it is untracked, you have to do it separately only. Am I making sense? Means you may now do git add file1 and commit separately. We have already seen that. But now because it's not a new file, I can add. A means add and commit. File1 modified. Got it? Now it should be clear. Understood the difference? Can you use git commit -a -m for untracked changes?
No.
No.
You cannot do this. This will not work here. That's a point you have to make a note of. Clear, everyone? So that's how your changes move from working directory to staging area and then to local repository. This is the architecture you should have always in your mind and learn the concept thoroughly with clarity. There'll be no confusion in it, right? Working directory, I'm again repeating. Tell me.
Yeah. I have one doubt. Like, if you're modifying your multiple files, and if we do commit, so the commit will all the changes for the multipliers will be committed, right?
See, whenever you run commit command, whatever in the staging area will be committed. Means if you do git commit -a -m means everything will be staged and committed.
Okay.
Got it? Let's suppose you want to commit only a particular file. Git commit, you can give that file name. Git commit, yeah, file name, correct, -m and the message. This will commit only this particular file. Otherwise, if you just run git commit, whatever in the staging area will be committed. And if you run this, it will be whatever in the working directory will be added and committed.
Okay.
And there is a question from Utkarsh. Unstage, you not use git add, then git commit. Did not get the question, Utkarsh. Unstaged, not use git add, then commit. Then unstaged changes will not be committed. Only the staged changes will be committed. That's what. Whatever in the staging area will be committed. Like in the architectural diagram also earlier I have shown you. You can't do this. Unstaged changes means here. From here to here, no. You have to move them to staging. Whenever you commit, whatever is in the staging area will be moved here. Not from here. Understood? From staging area to local. Not from working directory to local directory.
Once after we have added and committed, can we go back to the previous, like if I want to add one more word in the file one, like let's say by, hi, hello, and the by the third commit what we make, can we go back to the first version?
See, it's like you can modify these files at any point of time. If you are modifying now, let's suppose I'll just modify this. I don't want this. Hello. It's just a modification to Git. This is what you're talking about, right? Correct? I'll save it. It's just a modification. Now what will Git do? Git show us again unstaged. Now this is the new change. You can add and commit. Right? Now what I'll do? Git commit -m again modified. Or something like that. Right?
Just
It's
go to
just
the
a
git
change
log
with
once again,
respect to Git.
Preeti. So
Huh?
you can just go to the git log so that what has to be changed in that file.
It's just a modification.
Can we track that modification here in log?
With the commit message. One way is commit message. That's why you should give a proper message so that at a later point of time you can see what commits happen here. I'm giving dummy message. Generally, let's suppose it's a Terraform changes. You are creating EC2. You put a proper message so that you get some, you can make some sense like what it is all about. That's one way. Another way is git show. First 7 characters are enough. Okay. Git show. That will show you the changes happen. Do you see here? It was only this one, this line there. It was showing you the contents. Another way is if you want to see only the brief log, git log one line. It will just show you those first 7 characters and the commit message. That's how you can see what changes happen in that commit. Another way is you can also check the log of a particular file. Let's say I want to see the commits of this particular file. These are all the commits of that file one. Okay. See, Git is a tool where like it can be too vast. Means every command can have so many flags, so many options. Okay, you don't need to learn all those options, all those flags. No one knows that. You don't need to learn it. Then let's say there is a requirement. I have to use something. Git log. You can use help. Okay. Whenever you do this help, right? A browser will be launched with the Git manual. See, this browser got launched. Git log, that's a manual page of Git log command. Okay, here it will show you the synopsis, the description of what it does, examples. What are all the flags you can do? See, so many flags. We never use them in reality, but at times if you need anything, those are the different flags, different options you can look at with, right? That's how Git can be used. Like you can use all the manual pages if required. So that this is one of the flags, git log one line, so that it will show you brief log rather than the detailed log, right? These are the commands we have used till now. I'm just recapping the things. Git init, which has created the local repository. This command has created a local repository, right? Git init will create a local repository, empty repository. Thereby we created a files. Git add, git commit, git status to see the status, the position of your files, commit to move the changes to local repository, right? And git commit -a, - m, - - m if you have to add and commit the changes. These are the commands, and today we have seen the basic concept of how your changes moves from working directory to staging area and from staging area to local repository. Now we have to move our changes to remote. Many things are there. Okay, we'll be learning all the advanced concepts of Git so that you can clear any interview questions on Git. That's the agenda of learning any topic. You should clear your interviews and you should be able to work in the project. First, we were learning it from the perspective of managing the files. We will also learn to integrate it in the CI/CD pipeline. Any questions till this part from anyone?
Hi Preeti, Vishnu here.
Hi, Vishnu.
Yeah. Here you just crossed the git commit -a -m. Why it is crossed? I did not understand. Can you please explain that one?
-a means add and commit.
Here. Yeah.
Okay. If you want to add and commit together in the single command, you can do this. And you can do this only for unstaged changes, not untracked changes. Have you understood the difference between untracked and unstaged?
Yes.
So for if it is unstaged, means if it's not a single, not a new file, you can add and commit on a single line command. That's a command.
Okay.
Or else you can do separately also. Git add, git commit.
Yeah. Understood. Thanks.
Means it is for only modified file, correct?
Yes. Unstaged means modified files present in the working directory will be added and committed with this command. It's equivalent to add and commit.
Okay.
This is equivalent to this command is same as how you do git add and then you do git commit. It is same as that, but this can be used only for unstaged, not for untracked. Means for not a new file you can use it.
Yeah, it's not used in new file. It's used in only the existing file only.
Correct.
One more question, Preeti.
Yeah.
For bigger size, is it taking long time to push into Git or is it same time?
It will not take much. It will not show you much change, much difference. Okay, it will be a normal time only. It may take a couple of seconds more, but it's not beyond that.
Okay.
Preeti, when we have, sorry.
Tell me.
Preeti, you have used git show, and then you have put something like what is that?
Git show that commit ID. Whichever commit you want to see, you will get them in the log, right? Like in the log, you will see those commit IDs. So git show that commit ID, whichever ID you want to see. Means whichever, let's say I want to see the changes in a particular commit. That commit ID you have to provide.
And the change you have given that line 541, 542. What was the command which displayed all this thing?
Which thing? Git status?
No. I'm talking about just before that. You can see there are lines 536, 37, 38. All this. Which command has given us this
history?
Okay, history. This list of commands?
Yes.
History command. History command will give you the list of commands you have executed on your terminal. Clear command will help you clear your terminal.
It's almost same command for like Linux, correct?
Linux, yes. The git bash help you run your Linux, just provides a simple bash environment. But we will learn Linux separately. Here only few commands, whichever I'm using, I'm explaining. These are not Linux commands, okay? These are Git commands. These commands are same on Windows or anywhere, Windows, Linux or Mac. This is a Linux command.
When we have multiple files in staging, and if I want to commit one specific file with the message, how do we do that?
I have already explained this. Git commit file one and the message.
Okay.
Only that file you have to put file name. Yes. Okay.
Being a DevOps, how often do we use this Git, and for which all files we are going to use this?
Have you joined late, Roshan? Because this part we covered in the beginning. Have you joined late?
Yeah, I joined it. Around 20-30 minutes late.
No problem. Like actually, see, everyone should learn Git. Okay, developers will use to manage their program files. Testers, they have automation test scripts, they have to manage it. As a DevOps person, you do have so many config files, Terraform config files, Kubernetes manifest files, Ansible playbooks, whatnot. So many things are there. So even DevOps person should know it because they have to manage their own repos. Here we were learning it with demi files. Once we start Terraform, Kubernetes, Ansible, even Jenkins, we will be writing our own config files, our own scripts. Those will be version controlled. We will do that in our course as well. So first we are learning it with some sample files. Later on, we'll apply it to the actual files and the actual repos. That's the reason. And whatever commands I have used today, okay, everything were there in this drive, in this folder, okay. Here are the Git hands-on commands, whatever I have used. Here is the installation steps. Okay, here is the presentation with architectural diagram. This one, whatever I have used, that PDF is available here. Okay, not only that, if you go to our website, you have all the Git hands-on exercises, particularly the quiz. You are supposed to take up this quiz on daily basis. If you go to this quiz portal, go to Git, that's what we were starting now. You have to take up this quiz today after the session. We'll get the results. We'll also get your score so that we will keep tracking. You should also validate yourself. Retake it till you get a good score. Following all of you. So these are all the things you should do every day. As it is a day one, it's a small hands-on little things were there. As we go ahead, we'll get a very more scenario. So you should get started using this. Okay, this is all in the drive and this is in the website. And all of you, whoever have not joined, please join the WhatsApp group, and we'll be creating a separate WhatsApp group for all the registered students, like I have mentioned on the day one. Today or tomorrow, by the end of the day or tomorrow, we'll be creating a separate WhatsApp group with all registered students where you can post your queries when you do the hands-on. And also you will get a separate Zoom link from tomorrow that will be posted in the general WhatsApp group. So make sure to join that general WhatsApp group to get the updates. And we'll be creating a separate WhatsApp group by tomorrow or by today, end of the day. Any more questions from anyone?
Yeah, is it Git and the GitHub, is it same or is there any change? Git and GitHub.
They are not same. Git is a version control system, whereas GitHub is online management system, which works like a remote repository. So we'll be covering GitHub once we start our remote. And I would like to remind you, we did not start our remote repository set. We are still on local. Okay, we will push our changes to remote. There's a long way to go. Okay, so many things we have to do before we go to remote. Then we'll talk about GitHub as well.
Okay, thanks.
Any more queries from anyone else? Any questions, any concerns, anything else? All right then. So complete your hands-on, post your queries in the group, get in touch with the updates. Tomorrow onwards, a new Zoom link will be shared and all the registered students will be moved to a separate WhatsApp group. Any more questions, you can WhatsApp me or you can connect with Raj for the registration process.
Thank you.
All right then. Thank you everyone. Have a good day. See you all tomorrow.
Thank you.
Abhilash, you can message me on WhatsApp or else just give me a second. Here are the fee details. And, the number is on the website. You can also check the WhatsApp number on the website. I'm also sharing it here. Just give me a second.
How can we get this access to Google Drive?
Sorry, louder please.
So the Google Drive access, how can I get?
Yeah, once registered, you'll get access to all the course. Abhilash, have you got the details, the fee and the WhatsApp number?
Yeah, Preeti, got it.
All right then. Thank you. Thank you all. Have a good day. See you all tomorrow. Bye everyone.